All right, so in this problem, we've got to solve this equations. We're going to go from 0 to 360 degrees. So the basic process is we want to get the trig ratio on one side. We're going to use the inverse of the trig ratio to find one of the angles. But then what we've got to do is we've got to make sure that we find any other angles that will still fit within the range that are going to still give us this same value. And what we're going to do to make that happen is we're going to sketch it on the unit circle, and we're going to look for those other angles. And what we're going to do is, when it's a tangent, we're just going to add and subtract 180 degrees over and over again. And whatever angles we get, as long as we stay within the range, they're going to give us the same values. Sine and cosine, well, we're going to look across the x-axis for another cosine, and we're going to look across the y-axis for another sine. That'll give us another angle that'll match. And then what we're going to do is we're going to add and subtract 360 degrees to those angles to find other angles that are still within the range. So in this case, our range isn't very big. It's only from 0 to 360. And if we take the inverse of tangent 1.5, we'll find out that our angle is going to be 56.31 degrees, roughly. And so it is important to make sure that we are in the right mode for our calculators, the degrees, and it's a good idea to check the range to kind of make that happen. Anyway, so now what we're going to do is draw a quick little unit circle here. And if I'm going to sketch this angle, it doesn't have to be perfect, it's got to be even close. This is my 56.31 degrees. It's actually a reference angle, and it's tangent, so what I'm going to do is I'm going to add and subtract 180. Well, if I subtract 180, I'll go below 0, so that's no good, that's outside the range. So if I add 180, I'm going to get 236.31. And that's an angle that is within 0 to 360 degrees. That's this angle right here. So that's another answer. Now the thing is, if I go and add another 180 to 236, well, then I'm going to go over my 360 degree limit. So I know now that the only answers I am going to have are these two, 56.3 and 236.3. And go ahead and check it if you want to. Try doing tangent of 56.3, that's the angle, and see what you get. And then try tangent of 236.3 and see what you get. They're both going to give you 1.5, or approximately 1.5, because we rounded. Now in the next one, we're doing sine x is equal to 0.4. So the sine is by itself. We find the original angle by going ahead and doing the inverse sine, and I get 23.58 degrees. So now I'm going to go to my unit circle. I'm going to do a quick sketch. There's my 23.58 angle right there. And I'm looking for others that are going to give me the exact same value. So if I go across the y-axis and look there, I'm going to find that there's another angle that's going to result in the exact same thing. And if I consider 23.58 a reference angle, well, all I got to do then is take 180 and minus a 23.58, and that'll give me what that is. I'm going to find out that this angle is going to be 156.42. So that's my other angle. So right now I've got x is equal to 156.42 and x is equal to 23.58. Now the thing is, if I add another 360 or subtract another 360, am I still going to be within this range of 0 to 360? No, I'm not. So these are the only answers I've got, and they're the only ones I have to worry about. So my answers for this equation are going to be x is equal to 23.6 and x is equal to 156.4 degrees. All right, I hope that helps. Thanks for watching. And again, keep in mind, if I were to add 360 degrees to both these angles, they would still equal 0.4 when I put them in sine. They just don't fit within the range. I need to find the angles that are going to give me 0.4 that fit within the range they gave me. All right, I hope that helped. Thanks for watching.